In Heads Pro, there are 3 methods to design roads: 1. Workspace method of interactive design, 2. Project data file method for batch processing, and 3. Text data files method, old classic method. Method 1, Workspace method of interactive design 1.2, multiple section highway design. This method starts with one single file, which is the total station topographic survey data file survey.txt, and creates various reports, models, drawings, etc., and finally creates the project data file, which is the backup of all design data. In folder Work 2 the whole process is available. To open the project, user may double-click the project tag design job number 1.htr inside folder as Work 2 multiple section highway design project. To process data in workspace mode, Method 1, user may copy the files survey.txt in a folder, may be created as work, and process the design by following the steps described stepwise in this session. Step 1. Open main screen of Heads Pro. By double-clicking on the desktop icon, select menu item file, select working folder. Step 2. The folder is selected as exists, or user may browse and create and select a working folder. Step 3. Select menu item, file new/open project workspace highway design suit new/open multiple section highway design project. Step 4. Project workspace opens for multiple section highway design. Click on button create project. The project folder will be created as design job number 01 inside user's working folder. Message comes confirming that the project folder will be created. Click on OK. Step 5. Survey data option is selected as total station. Click on button browse to select the total station survey data file that exists at any location. Step 6. Select the total station survey data file survey.txt, may exist at any folder in some location. A copy of this file will be imported to user's project folder. Message comes confirming that a copy of this file is imported to user's project folder. Click on OK. Step 7. Open tab window process survey data. In this tab there are 3 more tabs. The first tab is opened as Step 1, Ground Model. Click on button create ground model. Step 8. As the process is over, the message comes. Click on OK. Step 9. The list of survey features comes. In column draw in the list, remove check mark for the feature to exclude it from the drawing. Click on the color box for feature drain. Select a desired color. Click on button apply. Step 9. In similar way, click on the color box for each feature and select a desired color for the respective feature. Click on button apply. This way colors are assigned to all features. Step 10. Click on button draw at the bottom of the list of all features. Step 11. The ground model is drawn with all the selected features. Step 12. Open tab window. Step 2. Triangulation under primary tab. Process survey data. Click on button create triangulation model. The process dialog box come. Click on button proceed. Step 13. As the process is over, the message comes mentioning about the output. Click on button OK. Step 14. Open tab window. Step 3. Contour under primary tab. Process survey data. By default the primary contour interval is shown as 1.0 m. The secondary contour interval is always 5 times of the primary interval. In case of a flat ground, the primary contour interval may be given as 0.1 mm and the secondary interval will be 0.5 m. The contour elevations will be written on secondary contours. Click on button create contour model. Step 15. The process dialog box comes. Click on button run. The contour window opens and shows the process of creating contours on the triangulation model. Step 16. As the process is over, click on the button save on top panel of the contour window. Step 17. Next, click on yellow color contour icon at the bottom panel of the contour window. As the dialog box comes, click on the button Quit to close the contour window. Step 18, next, we are back to the tab for contour in the project workspace, click on button, Draw Contour Model. Contours are being drawn and wait for some time. The contour model is drawn over the ground model. Step 19, Open tab window Highway Design. In this tab there are 8 more tabs for steps 4 through 11. The first tab is opened as Step 4, Horizontal Alignment. User may either select the option Process Halon Design Data. Step 20, Paste the Halon data in the lower left box. And by clicking on button Proceed, the Halon data will be processed and the model will be saved with center line string M001 under Model Name Design in Model Files. Step 21, or alternatively, user may select the option New Halon Design and click on button Proceed to design the alignment interactively. Step 22, click on icon on the right side of the window or drawing a polyline, and click on a number of points on the contour drawing to draw a polyline. To finish the polyline, click the right mouse button. The polyline should pass through the center of the contours. The points should be sufficiently away from each other to accommodate curves to be set at these points. These points are called horizontal intersection points, HIP. Step 23, select menu item Design Halonment New HIP method. Step 24, click the left and then right mouse buttons on the polyline. Step 25, the design dialog box comes. User may change the data as desired, click on button Apply. Step 26, message comes saying that the curve is large at a HIP, reduce the curve radius to 500 meters, necessary lead and trail transition curves may be entered as per the design standard, click on OK. Step 27, similarly, upon clicking on button Apply each time, if some other curves are found large at other HIPs then, reduce the curve's radius as suitable, necessary lead and trail transition curves may be entered as per the design standard. By minimizing the design dialog box the alignment can be checked. Selecting menu item Design Shehnage on or Design Details on, the shehnage and details can be seen. Step 28, if no more message comes for large curves then click on button Save and Finish. Step 29, next comes the dialog box for modeling the design, select the string M001, click on OK. Step 30, the modeling process dialog box comes, click on button Proceed. Step 31, as the modeling process is over, the message comes, click on OK, close the design window heads viewer. Step 32, now we are back to the window for step 4 in the design workspace, click on button View Halon Design. Step 33, the pop-up dialog box comes, select the string M001, click on OK. The Halon design data is displayed on the left side box. Step 34, the alignment with tangents and curves is drawn, this is just for viewing only. Step 35, click on button Shehnage on, the dialog box comes, select the string M001 and enter other details, click on OK. Step 35, the shehnages are displayed along the alignment of the road center line, next, click on button Details on. Step 36, the dialog box comes, select the string M001 and enter other details, click on OK. Step 37, the curve details are displayed along the alignment of the road center line. Step 38, open the next tab. Step 5, Design Vertical Profile, via line, click on button Create Ground Long Section. Step 39, the Process dialog box comes, click on button Proceed. Step 40, as the process is over the string E001 for the ground long section along the road center line is stored in the model files and the message comes, click on OK. Step 40, click on the button Draw Ground Long Section, the dialog box comes, the default horizontal and vertical scales are mentioned, click on OK. Step 41, next user may either select the option Process via line design data. Paste the via line data in the lower left box. Step 42, click on button Proceed, the via line data will be processed and the model will be saved with center line string M001 under model name design in model files. Step 43, or alternatively, user may select the option New via line design, and click on button Proceed. Step 44, the heads viewer opens as the design window, select menu items as Design Ground Long Section Draw Vertical Profile. Step 45, the dialog box comes, select the model design. Step 46, select the string E001, click on OK. Step 47, the ground long section is displayed, click on icon on the right side of the window for drawing a polyline, and click on a number of points on the ground long section to draw a polyline. To finish the polyline, click the right mouse button. The polyline should pass as close as possible to the ground long section, the points should be sufficiently away from each other to accommodate curves to be set at these points. These points are called vertical intersection points, VIP. Step 48, select the menu items as Design via Alignment New VIP DSN. Step 49, click the left and right mouse buttons on the polyline. Step 50, the design dialog box comes, user may change the data as desired, click on button Apply. Step 51, if any message comes for large curve, the vertical curve length, VCL, is to be reduced, and again click on Apply. If no message comes, then click on button Save and Finish. Step 52, next comes the dialog box for modeling the design, select the string M001, click on OK. Step 53, as the process dialog box comes, click on Proceed. Step 54, as the process is over, the message comes, click on OK, close the design window heads viewer. Step 55, now we are back to the window for step 5 in the design workspace, click on button Draw Vertical Profile. Step 56, the dialog box comes, select the string M001 and click on OK. Step 57, the designed vertical profile for the center line of the road is drawn, the via line design data is displayed on the left side box, click on button Grid On. Step 58, the dialog box comes, the default parameters are mentioned and click on OK. Step 59, the grids are displayed with 1:10 scale over the designed vertical profile of the road center line, Chinachs are displayed at the bottom and elevations are displayed at the left vertical side. Step 60, click on button Vertical Details On, the dialog box comes, select the string M001, click on button OK. Step 61, the design vertical details are displayed along the vertical profile of the road center line. Step 62, next, the tab window Step 6 for selecting the typical cross-section, TCS, is opened. There are 9 TCS are available, as this is a multiple cross-section highway, so from start to end the cross-sections are different and a specific TCS is to be applied for the range of respective Shenage stretches along the alignment of the road. User may click on a TCS and may see the particular TCS. Step 66, finally, click on button Save Schedule Data to save the schedule of cross-sections elected for different change ranges. Step 67, the message comes mentioning that the selected cross-section schedule is saved, and next the dimensions for various cross-section elements are to be entered by selecting a range from the list in the schedule. Step 68, next, the tab Step 7 is opened to define the dimensions of various cross-section elements. There are 3 tabs under the current tab. The tab Define Cross-Sections is opened, select a range from the list in the schedule, the default data for the dimensions are given. User may change the data as desired, in unauthorized version the change in data is not accepted. Step 69, click on button Save Data, the message comes, click on OK. Step 70, next, we open the tab page interface to define the slopes and berms. The details of the data is given, user may change the data as desired, the data is explained in Heads Pro main screen help. Step 71, next, we open the tab page Create Cross Sections, click on button Process Cross Section Data. Step 72, the process dialog box comes with various design actions, each one is to be processed one after another, click on button Proceed. Step 73, the first process starts to create 3 strings CL01, CL02, CL03 on the left side and strings CR01, CR02, CR03 on the right side forming the central median, click on button Proceed. Step 74, as the process is over the message comes, click on OK. Step 75, the next process will create the super elevated left carriageway edge as string CL04 in the model files, click on button Proceed. Step 76, as the process is over the message comes, click on OK and Finish. Step 77, the next process will create the super elevated right carriageway edge as string CR04 in the model files, click on button Proceed. Step 78, as the process is over the message comes, click on OK and Finish. Step 79, the next process will create the super elevated left paved shoulder edge as string CL05 in the model files, click on button Proceed. Step 80, as the process is over the message comes, click on OK and Finish. Step 81, the next process will create the super elevated right paved shoulder edge as string CR05 in the model files, click on button Proceed. Step 82, as the process is over the message comes, click on OK and Finish. Step 83, the next process will create the left and right edges of the earthen shoulders as strings CL06 and CR06 respectively in the model files, click on button Proceed. Step 84, as the process is over the message comes, click on OK. Step 85, the next process will create offset strings as CL07 and CR07 to make CL06 and CR06 as continuous strings and to store in the model files, click on button Proceed. Step 86, as the process is over the message comes, click on OK. Step 87, the next process will create the cross-section of the road top formation, by uniting all the strings from CL01 through CL07 on the left side of the center line and strings from CR01 through CR07 on the right side of the center line, in actual sequence of their occurrences in the cross-section. Click on button Proceed. Step 88, the message comes as shown, click on OK. Step 89, the next message comes as shown, click on OK. Step 90, as the process is over, the cross-sections are created in text file HDS002.fill, the message comes as shown, click on OK. Step 91, the next process will create 2 additional offset strings required for elevated sections present in the schedule, click on button Proceed. Step 92, as the process is over the offset strings are saved in the model files, the message comes as shown, click on OK and Finish. Step 93, the string for ground long section is to be created under the left offset string of the 2 offset strings which was just created in the previous step, click on button Proceed. Step 94, the message comes as displayed, click on OK. Step 95, as the process is over the ground long section string is created, message comes as displayed, click on OK. Step 96, the string for ground long section is to be created under the right offset string of the 2 offset strings which was just created, the message comes click on OK. Step 97, as the process is over the ground long section string is created, message comes as displayed, click on OK. Step 98, referring to the ground long section string on the left side just created another additional pair of offset strings are to be created on the left and right ends for the end elements in a cross section in the schedule, click on button Proceed. Step 99, as the process is over the 2 offset strings are created, message comes, click on OK. Step 100. The next process will create the cross-section of the road formation without the side slopes. Click on button Proceed. Step 101. The message comes as shown. Click on OK. Step 102. Another message comes as shown. Click on OK. Step 103. As the process is over, the cross-sections without side slopes are created in text files hds002.fill. The message comes as shown. Click on OK and finish. Step 104. In this step the cross-sections at various Shehnage ranges are joined/updated. Message comes. Click on button Proceed. Step 105. The cross-sections with side slopes are to be created by interface. The process dialog box comes as shown. Click on button Proceed. Step 106. The message comes as shown. Click on OK. Step 107. As the process is over, the cross-sections with side slopes are created in text files hds003.fill and hds003a.fill. The interface strings are saved as I001 in the model files. The message comes as shown. Click on OK and finish. Step 108. As all the processes are over, click on button Finish at the right side as shown. Step 109. The dialog box comes with list of all strings. Click on button Draw Strings. The strings are being drawn. Please wait. Step 110. The strings are drawn. Click on button Create cross-section drawings on the left side of the window. Step 111. The cross-sections are being drawn. Please wait. These are for viewing only. Step 112. Select a Shehnage as shown to view the cross-section, and the cross-section at that particular Shehnage will be displayed. Step 113. User has to check the cross-section at that Shehnage on the left side, with the plan view as displayed on the right side of the window. Step 114. The tab page Step 8 is opened for defining pavement layers. Inclusion of pavement layers is important because the thickness of the layers may result in cut at a cross-section, while the section may initially be in fill. Click on button Define Pavement Layers. Step 115. The dialog box comes with default data for various pavement layers. Select each cross-section from the schedule of cross-sections by serial number to the existence of service roads of elevated structure and to define pavement layers accordingly. The values for HO and VO are mentioned as start and end distances of each layer with respect to the road center line. User may change the HO and VO values as desired. Select range 1 of the schedule, define layers, click on button Save. Step 116. Select each range of Shehnages of the schedule, define layers, finally click on button Save. Step 117. The message comes as shown. Click on buttons OK and finish. Step 118. We are back to tab Step 8 in the workspace. The pavement layers data is displayed on the left side. Click on button Process Data. Step 119. The process dialog box comes. Click on button Proceed. Step 120. The message comes as shown. Click on OK. Step 121. As the process is over, the message comes. Click on buttons OK and finish. Step 122. The tab page Step 9 is opened for volume to compute the quantities for earthwork and pavement layers. Click on button Process Data. Step 123. The process dialog box comes. Click on button Proceed. Step 124. As the process is over, the message comes. Click on buttons OK and finish. Step 125. The result is displayed on right lower panel, and the report is written in file volume.rep. Step 126. The tab page Step 10 is opened. Under this tab there are 4 more tabs. Currently the tab Alignment Schematics is open to create the drawings for schematic drawings for horizontal and vertical alignments. Click on button Process Data. Step 127. The process starts to create schematic drawing for the horizontal alignment and the dialog box comes. Click on button Proceed. Step 128. As the process is over, the message comes, click on buttons OK and Finish. Step 129. The next process starts to create schematic drawing for the vertical alignment and the dialog box comes, click on button Proceed. Step 130. As the process is over, the message comes, click on buttons OK and Finish. Step 131. Next, the tab Plan is opened, that exists under the tab page. Step 10. To create the plan drawing, the various data is given, user may change the data as desired, refer to Heads Pro main screen help to understand the data, click on button Process Data. Step 132. The process starts to create one single plan drawing or a set of plan drawings at an user given Schenage interval. This is described in the Heads Pro main screen help. The dialog box comes, click on button Proceed. Step 133. As the process is over, the message comes, click on buttons OK and Finish. Step 134. Next, the tab Profile is opened, that exists under the tab page. Step 10. To create the profile, long section, drawing, the various data is given, user may change the data as desired, refer to Heads Pro main screen help to understand the data, click on button Process Data. Step 135. The process starts to create one single profile drawing or a set of profile drawings at an user given Schenage interval. This is described in the Heads Pro main screen help. The dialog box comes, click on button Proceed. Step 136. As the process is over, the message comes, a set of 4 profile drawings are created at an user given Schenage interval of 1000 meters, click on buttons OK and Finish. Step 137. Next, the tab Cross Section is opened, that exists under the tab page. Step 10. To create the cross-section drawing, the various data is given, user may change the data as desired, refer to Heads Pro main screen help to understand the data, click on button Process Data. Step 138. The process starts to create one single cross-section drawing or a set of cross-section drawings at an user given Schenage interval and drawing sheet size. This is described in the Heads Pro main screen help. The dialog box comes, click on button Proceed. Step 139. As the process is over, the message comes, a set of 20 cross-section drawings are created at an user given Schenage interval, click on buttons OK and Finish. Step 140. The tab page. Step 11 is opened in the Design workspace. Under this tab there are 6 buttons, click on the button Create/Update Project Data File. Step 141. The project data file is created and the message comes, click on OK. Step 142. Click on the button Open Project Data File. The project data file is displayed on the screen and is also opened in Notepad to take printouts. This the back file of the design data and may be processed along with the total station survey data file by taking these two files in a new folder. Step 143. Click on the button View Survey Data File. The total station survey data file is opened in Notepad to view or to take printouts. Step 144. Click on the button View Report Files. Step 145. The window opens with a list of report files on the left side. Select a report and the report file is displayed to view or to take printouts. Step 146. Click on the button View Drawings. Step 147. The message box comes, click on button Yes. Step 148. The Heads CAD viewer opens with a list of various drawings created inside a folder Design Drawings. Inside the project folder that was created at the start of this session under the working folder select by the user, select a drawing in the list and the drawing is displayed to save or print. After viewing the drawings, close the CAD viewer without saving the drawings. In unauthorized version of Heads Pro the drawings cannot be saved or printed. Step 150. By clicking on the button Open Viewer, user can open the Heads CAD viewer. Step 151. we are again back to the tab page. Step 11 of the project workspace, close the project workspace. The message comes asking whether to save/update the project data file. Click on button Yes. Step 152, the message comes, click on OK. This is the end of session 4 Method 1, Workspace Method of Interactive Design 1.2, Multiple Section Highway Design.